Hi guys, maayong adlaw. For this video, my presentation is about the intercepts, zeros, and asymptotes of logarithmic function with a translation of the graph of logarithmic function. For the lesson objectives, at the end of this video, you should be able to find the intercepts, zeros, and asymptotes of logarithmic function and interpret the translation of the graph of logarithmic function. This lesson requires us to have a prior knowledge in the following: finding the domain and range of logarithmic function. Then number 2, graph of logarithmic function. Now, since logarithmic function is just the inverse of exponential function, let us analyze first the graph of the general form of exponential function. So, for example, we are given the graph of the exponential function. The graph of the exponential function in general form shall always cross at the point 0, 1. Then, for example, this is our graph of exponential function, of course, with our horizontal asymptote at y equals 0 or the line x-axis. So this graph is the graph of the exponential function in general form y equals b raised to x. Now, if we are to plot the graph of the logarithmic function in general form, we will have this graph. Since the graph of the logarithmic function is just an inverse of exponential, so instead of having our point in exponential here at 0, 1, in logarithmic that will be in 1, 0. And of course, we choose one point along the graph. Our line x equals 0 or the y-axis is our vertical asymptote. So if we have the horizontal asymptote in exponential, we will have the vertical asymptote in logarithmic function. Now, if we are going to find the x-intercept for this graph, as you can see, the graph crosses the x-axis at point 1, 0. So therefore, our x-intercept is at point 1, 0. Now, how about the y-intercept? As you can see, as I've said, the graph will approach the y-axis but will never cross the y-axis because our y-axis also serves as our vertical asymptote. So therefore, for this specific graph of the general form for logarithmic function is none. So the graph will not cross the y-axis, so there is no y-intercept. Now for the zero of the function, we will just simply take the x value in the x-intercept, which is 1. So our 0 is x equals 1. Why? Because, as I have mentioned in my previous video, log of 1 to any base is just equal to 0. So if this is 1, the whole function, the whole logarithmic expression will become 0. That's why the value of 1, the value of x that will make the whole function 0 is 1 for this specific general form for logarithmic function in any base. And of course, our vertical asymptote is the line x equals 0 for the y-axis. Now, I would like to emphasize that the x-intercept, y-intercept, 0, and the vertical asymptote to a given general form of logarithmic function are the same. Okay, let's proceed to example number 1. For example, we are to plot the graph of y equals log of x minus 2 to the base 3 plus 3. Now this time, we will take the graph one by one. So let us plot first the graph of y equals log of x base 3, which is in general form. So let us exclude first the negative 2, the horizontal translation, and the vertical translation, which is the h and the k. So let us plot first the general form, which is y equals log of x base 3. As I've said, the graph of general form, a logarithmic function in any base shall always cross the point 1, 0. Now, if we have to choose one point along this line here and connect these 2 points by a curved line, so we will have this graph. And of course, we also have the y-axis as our vertical asymptote for the line x equals 0. So this graph is the graph of the function y equals log of x base 3. Since this is in general form, so as I've said earlier, our x-intercept is 1, 0. our y-intercept is none because the graph will not cross the y-axis. Then our 0 is the same, x equals 1. And of course, the vertical asymptote is x equals 0 or the y-axis. So this is in general form. How about we will include the translation? We will include the horizontal translation, which is -2. Let us not include yet +3. So let us plot the graph of y equals log of x minus 2 to the base 3. Let us not include +3. So this time, since this h is our horizontal translation and this is -2 or -2, our graph will move 2 units to the right. 2 units to the right. So what will happen to the graph? Meaning, this point here, which is 1, 0, will move 2 units to the right. So this will move 1 and 2. So this is now the new location of this point here. And of course, as the graph moves 2 units to the right, the same also with the vertical asymptote will also move 2 units to the right. So from the vertical asymptote as x equals 0, this will move 2 units to the right. This time our new vertical asymptote is the x equals 2. So if we are going to illustrate this one, the graph will move 2 units to the right. So our original point is located here, moves 2 units to the right, 1 and 2. This one here, original point is located here. So this will move 2 units to the right. So we have 1 and 2. This is now our graph. Of course, our vertical asymptote will be the x equals 2. So this graph is now the graph of y equals log of x minus 2 base 3. We are going to find the x-intercept for this graph. Of course, we will now have our new x-intercept, which is the point 3, 0. Because this time our graph crossed the x-axis at point 3, 0. Then, of course, since the graph will not cross this vertical asymptote, of course, there is no way that this graph will also cross the y-axis. Therefore, our y-intercept is none. Then, the 0 of the function is 3. We will just simply take the x value in the x-intercept, which is 3. And of course, the vertical asymptote is +2, which is this line here. Now let's continue. If we will include the +3 here, so we will plot the whole function. So y equals log of x minus 2 base 3 plus 3. Now the +3 here indicates the vertical translation of the graph. So from the original point here, our graph will move 3 units up, so 1, 2, and 3. And of course, this point will also move 3 units upward. For the vertical asymptote, since the graph will only move upward, the vertical asymptote will not change. So the vertical asymptote remains at x equals 2. So if we are going to illustrate the vertical translation, 3 units upward, the graph becomes like this. So from the original location of the point, we have here 3, moves 3 units upward, so this becomes 1, 2, and 3. And of course, from the original point here, 1, 2, and 3. Connect the points with a curved line, so this is now our graph, and of course, with the vertical asymptotes still remains at x equals 2. So this is now the graph of the function y equals log of x minus 2 base 3 plus 3. X-intercept now is approximately at point 2 and 1 over 7. So how did we get 2 and 1 over 7 here? Since this is the x-intercept, we just simply set the value of y to 0 and solve for x. So we will use subtraction property here, this minus 3, then change to exponential, then simplify. We will have 2 and 1 over 7 and 0. So approximately this point here. And of course, the same, since the graph will not cross this vertical asymptote, of course, more so, it will not cross the y-axis. So therefore, our y-intercept is none. Then the 0 of the function is x equals 2 and 1 over 7. And of course, the vertical asymptote is x equals 2. Okay, let's proceed to example number 2. For example, we are to plot the graph of this function. Y equals negative log of x base 5. This time, this graph is still in the general form for logarithmic function. The difference is that we have the negative before the log. Okay, so let us proceed to the reference function, which is the positive, the general form for logarithmic function. We have here the graph. We have here the vertical asymptote. The graph, again, since this is in general form, the graph will cross the point 1, 0. So this graph is the graph of the function y equals log of x base 5. As you can see, this is positive. Here, this is negative. So what will happen to the graph if we are to plot this graph here? The graph of this function is just the reflection of the graph of this function, which is the positive, along the x-axis. This is just the same because we are in general form. Now, the graph of this function is just a reflection of the graph of this function along the x-axis. So what will happen to the graph of this function if we are to plot the graph of this function? The graph will look like this. And still, since this is in general form, of course, our graph will still cross the point 1, 0. Again, we still have the vertical asymptote at x equals 0, which is the x-axis. So, since this is in general form, x-intercept, y-intercept, 0, and the vertical asymptotes are just the same. What if we are to plot the graph of y equals negative log of x plus 5 base 5? This time, we added the horizontal translation, which is positive 5. So, if this is positive 5, this is our reference graph now. We have the negative. The graph will move 5 units to the left. So, the same as with the vertical asymptote will also move 5 units to the left. So, from 0, it will move 5 units. So, 1, 2, 3, 4, 5. So, this is now our new vertical asymptote, which is the line x equals negative 5. And of course, the points also will move 5 units to the left. So, we have 1, 2, 3, 4, 5. And the same as with this point here. Therefore, this is now the graph of the function y equals negative log of x plus 5 base 5. Okay? So this is now the new vertical asymptote, the new x-intercept. This time, we now have the y-intercept. The graph crossed the point 0, negative 1. The graph intersect the point 0, negative 1. So, if we are to identify the x-intercept of this graph, we will have the x-intercept at negative 4 and 0, this point here. And the y-intercept is 0, negative 1, this point here. So, how did we get this point? Substitute, since this is y-intercept, substitute, we set the value of x to 0, so 0 plus 5, 0 plus 5 is 5, and the same base. Log of the same base, if the value here is equal to the base, so therefore the log becomes equal to 1, and we have the negative, that's why we have negative 1. So the graph will cross the point 0, negative 1. And the 0 of the function is of course x equals negative 4, and the vertical asymptote is x equals negative 5, this line here. What if we are to plot the graph of y equals log of x plus 5 base 5? Instead of having the negative here, we have positive. Okay, so what will happen to the graph? The graph will look like this. The graph of this function will cross the point approximately. This is not just accurate. The graph is not just accurate. It's approximately the graph cross at the point or intersect the point 0, positive 1. Okay, so this is now the same. The vertical asymptote is the same. What that is x equals negative 5. Then we have the x-intercept, the same, which is negative 4 and 0. The y-intercept this time is the positive, is the 0, or is the point 0 and 1. Then our 0 of the function is of course negative 4. And our vertical asymptote is the same, x equals negative 5. Another example. What if we are to plot the graph of this function? Y equals log of x plus 2 base 2 minus 4. So again, let us have the reference graph, which is the general form, log of x base 2. Okay, this is y equals log of x base 2. We have again our x-intercept, the y-intercept, the 0, and the vertical asymptote are the same because we have the general form. So what if we are to plot the graph of y equals log of x plus 2 base 2, excluding the vertical translation? We will have first the horizontal translation. Since this is plus 2, meaning the graph will move 2 units to the left. So 2 units to the left. This is our vertical asymptote. This will move 2 units to the left. So 1, 2. Therefore, our new vertical asymptote will be the line x equals 2. And of course, this point also will move 2 units to the left. So this is now the new graph. This is now the graph of y equals log of x plus 2 base 2. So if we are going to identify, the x-intercept is at negative 1, 0. This time, our y-intercept is the point 0, 1. And the 0 of the function is, of course, x equals negative 1. We just simply take the value of x and the x-intercept. And of course, the vertical asymptote is the line x equals negative 2. Now, how about we will include negative 4? So we'll include the horizontal translation and the vertical translation. So, since this is the vertical translation and this is negative 4, that means the graph will move 4 units downward. Okay? 4 units downward. But our vertical asymptote stays the same. Only the graph will move 4 units downward. So this point will move 4 units downward. So 1, 2, 3, 4. So this is now the new location of that point. Another point, 1, 2, 3, 4. So if we have the graph like this, 4 units downward. This is the original, the location of this point is here. So 1, 2, 3, 4. And the location, the original location of this point is here. So we have 1, 2, 3, 4. And the same as with this point, and the vertical asymptote stays the same. So if we are going to identify the x-intercept, we set the value of y to 0 and simplify, change to exponential and simplify. We will get x-intercept as 14 and 0. It will extend infinitely to the right. So eventually it will cross the point 14 and 0. But the y-intercept is at point 0, negative 3. And the 0 of the function is x equals 14. And of course, our vertical asymptote is the same at x equals negative 2. Okay, let's proceed to next example. How about we are to plot the graph of y equals log of x base 7. So as you can see, this graph is in general form. So if we are to plot the graph of this function, we will have this graph here. The graph will cross at point 1, 0. We have the vertical asymptote at x equals 0. So approximately, this is now the graph of y equals log of x base 7. So since this is in general form. How about we are to plot the graph of the function y equals negative log of x base 7. This time we have the negative. As I've said earlier in my previous example that the graph of this function with the negative is just a reflection of the graph of the original function. But remember, this is still in general form. So the reflection of the graph along the x-axis. Therefore, the graph will look like this. Since still this is in general form, the graph crossed at the point 1, 0. And of course, we still have the vertical asymptote at x equals 0. How about we are to plot the graph of, this time, we have the horizontal translation of positive 3. The same, y equals negative log of x plus 3 base 7. Now we have the horizontal translation of positive 3. That means this graph will move 3 units to the left. So our vertical asymptote will also move 3 units to the left. So from this original vertical asymptote, we will have 1, 2, 3. So this is now our new vertical asymptote. Then the point will also move 3 units to the left. So the graph of this function will look like this. Okay, this is now the graph of this function. How about we are to plot the graph of y equals negative log of x plus 3 base 7 minus 2. This time, we now have the vertical translation, which is negative 2. The graph will move 2 units downward. Okay? But since this is vertical translation, or the vertical asymptote will not change, only the graph will move 2 units downward. So therefore, the graph will look like this. 2 units downward. Next example. How about we are to plot the graph of this function? Y equals log of x minus 1 base 4 plus 4. So this is our Cartesian plane. Of course, we plot first the general form, which is log of x base 4. Then we will include the horizontal translation, which is minus 1. So therefore, the graph will move 1 unit to the right. So the vertical asymptote becomes this line here, and this point will move to this point here, and also this point will move to this point here. So the new graph will look like this. So y equals log of x minus 1 base 4 with the horizontal translation of minus 1. This time we will include the vertical translation, which is the positive 4. So since this is vertical translation, it's positive 4, the graph will move 4 units upward, but the vertical asymptote stays the same. So the graph will look like this. Okay, that is now the graph of this new function. We will have this code. Thank you and God bless. Again, do not forget to subscribe, like, and share to your friends, especially those who are incoming grade 11 students.